Okay, let's remind ourselves of the graphs of these functions. So for sine, as theta goes from 0 to pi to 2 pi, we have this sine wave. Like that. And because so this is sine theta and cos theta. And for tan, the graph looks like this. Okay. Right. And I'm writing in pi and 2 pi. And these points where tan is not defined. So note, domain of tan is the thetas such that theta is not equal to -3/2 pi minus half pi, half pi, 3 over 2 pi, so on. Whereas the domain of sine and the domain of cosine are both R. And what about the range? So range of sine and cosine are -1 to 1, closed interval, and range of tan is the whole of R. So about periodicity, we can take P equals 2 pi for all three, but we can take P equals pi for 10. And of course that P is smaller, so we get periods two pi for sine and cos, and pi for tan. So odd or even functions, this means definition f is even if fx is f of minus x for all x. And f is odd if the same is true but with a minus sign. So for example, sine is odd, and picture is by x-axis some angle theta this way gives me the point xy, but so that implies that sine theta, oh, I made a mistake here, I need to put in a minus. If sine theta is x over y, and sine minus theta is x over minus y, then sine theta is minus of sine minus theta. So it's odd. identities between trigonometric functions. So for instance, if I have a triangle or better, I have an angle theta in standard position. This line has length 1. And then by Pythagoras, x squared plus y squared is 1. But also, sine theta is y over 1. That's just y. Cos theta is x over 1, which is just x. So we get that sine squared theta plus cos squared theta. Okay, so meaning here is sine theta squared. So if I know the value of sine, I can use this to calculate cos by solving the equation. Okay, so some more trigonometric functions. The cosecant of theta is 1 over sine theta. The cosecant. The secant of theta is 1 over cos theta. And the cotangent of theta is 1 over tan theta. So we can see the book for graphs. So it's very easy to calculate these other trigonometric functions that these words are sometimes used to save time. And we can deduce if I divide by cos squared in this, that 1 plus tan squared is sec squared theta. So note, both sides have same domain. So the domain of sec theta is where cos theta is non-zero, and that's the same as domain of tan theta. So let me write that down. So the domain of tan is the set of theta in R such that cos theta is not zero. The trigonometric functions to different kinds of triangles. So let's take a triangle with sides A, B, C, and this angle theta. Now let's put angle in standard position. So we have our x-axis here. And then this is the side of length B. This side of length A, and this side of length C. And the angle in standard position is like this. So this is y-axis. Now we know the coordinates of these 2 points. This one is B0, and this one, by definition of cos and sine, is A cos theta, A sine theta. So in this case, cos is negative. So then, by Pythagoras, the square of C, the distance between those 2 points, can be calculated from those coordinates. And now I can simplify this with the identity I gave above. So I square, expand the square, expand both squares, like that, and then I can collect terms. Oh, I forgot an important term here. This is cos theta. Minus 2ab cos theta. But this, we said, always equals 1. So we get this result. So this generalizes Pythagoras. If we put theta is pi over 2, so 90 degrees, a right angle, then cos pi over 2 is 0, and so we get c squared is a squared plus b squared. Okay, so coming back to the app, see if there are any questions on this. Yeah, so thanks about the odd function. So this formula can be useful for calculating lengths in a triangle. Or angles if you know the lengths. So now I want to introduce formula for sum of angles. So if I have an angle in standard position, A, and another one not in standard position, B, then I can put these together to a single angle A plus B. And then because of A plus B, you can write as causes and sines of the two angles. Now, so if I replace B with minus B, I get this. And using that sine is odd and cos is even, I get that cos A minus B, oh, there should be a minus here, is cos A cos B. Two minuses become a plus to make sine A sine B. So we have these two formulae. So note, can prove using law of cosines and that's in this week's homework. So this gives us cos x plus pi over 2 is minus sine x. So why is this? Because cos of pi over 2 is 0, and sine of pi over 2 is 1. So check this. Agrees with the graphs and those rules we gave for writing a graph of cos x plus pi over 2 from graph of cos x. And from the other formula, which is at the top of the screen now, cos x minus pi over 2 is sine x. So it's good to memorize the pattern of coses and sines in this formula. But it's a nice pattern. So 2 coses and 2 sines, like that. And why is this formula useful? Well, to calculate sine of 2 pi over 3 without a calculator, I can use this formula to write it like this. And then it becomes something I already know, cos pi over 6 from this triangle So from that triangle, cos pi over 6 is the square root of 3 over 2. So to get that, I have to rotate the triangle so it's in standard position. So this is pi over 6. This is root 3, that's x. And this is 2. So also, we have formulas for the sines, you can read about how to prove these in the book. Again, the pattern of causes and sines like this. And in the same way, we get a formula for sine a minus b. Using that cos is even and sine is odd. Because sine is odd, we get this minus sign here. Okay. And we can use these to calculate the values of trigonometric functions at different thetas. So to calculate sine of 7 pi over 12, notice this is pi over 4 plus pi over 3. And so from the formula above, this is sine pi over 4, cos pi over 3, cos pi over 4, sine pi over 3, and I still have this triangle, which gives me the sine and cos of pi over 4. They're both 1 over square root of 2. And the cos of pi over 3 from this triangle at the top is, I'm going to copy it in again so we can see. It can be confusing. So cos of pi over 3 is 1 over 2. And sine of pi over 3 is square root of 3 over 2. So we can simplify a little bit to 1 plus square root of 3 equals 1 plus square root of 3 over 2 square root of 2. So, give some context for that. If I try to draw the graph to check that this is right, so if I have theta going from 0 to pi, then the graph of sine theta looks like this. So at pi over 2, it reaches its maximum value. And we're looking to calculate at pi over 6 more than that. So this is theta 7 pi over 12. So we expect the value of sine theta to be a little bit less than the maximum value 1. So I can check my computer or calculator. This is about 0.97. Okay, so coming back to the chat, see if there's any questions. No, okay. So let's continue. So the double angle formulas. So this is the case where I have an angle theta in standard position, and I double it like that. So same as the combined angle 2 theta. And then if I put A equals B equals theta, I get that cos 2 theta is cos squared theta minus sine squared theta, and sine 2 theta is 2 sine theta cos theta. So that lets me calculate from sine and cos for theta, lets me calculate sine and cos for 2 theta. What about the other way around? So let's call these 1 and 2. So 1 implies that cos 2 theta is cos squared theta minus 1 minus cos squared theta. Which of course simplifies. And that's using the identity we gave earlier. And that of course implies that cos squared theta is 1 plus cos 2 theta over 2. And similarly, 2 implies that oh no, I mean 1 implies that cos 2 theta is 1 minus sine squared theta minus sine squared theta. And so we get a formula that sine squared is 1 minus cos 2. So if you know sine and cos for 2 theta, can calculate sine and cos for theta by taking a square root. Okay, so note, be careful. Sine theta cos theta, as we know, can be positive or negative. Okay, so that's enough on trigonometric functions. So next time, next lesson, we will start on rates of change and limits. So we are still working towards being able to calculate the slope of a curve like this. And all the applications of that. Okay, so let's finish there and let me know if you have any questions.